Problem number 460, LFU Cache. Design and implement a data structure for least frequently used LFU Cache. Implement the LFU Cache class. Its initialization will initialize the object with the capacity of the data structure. The get function will get the value of the key if the key exists in the cache, otherwise returns -1. The put function will update the value of the key if present or inserts the key if not already present. When the cache reaches its capacity, it should invalidate and remove the least frequently used key before inserting a new item. For this problem, when there is a tie, 2 or more keys with the same frequency, the least recently used key would be invalidated. To determine the least frequently used key, a use counter is maintained for each key in the cache. The key with the smallest use counter is the least frequently used key. When a key is first inserted into the cache, its use counter is set to 1. The use counter for a key in the cache is incremented either a get or put operation is called on it. The function get and put must each run in O1 average time complexity. Okay, so yeah, we need to choose the data structure. I think we can maintain the same one with LRU, like doubly linked list with the map, and the map can store the key value, the node, and its frequency. So wait, no. We should have a counter that can always tell us which node has a least frequency, and I think it will be a heap. So a length heap. So the heap will. But yeah, if we use heap, then it's difficult to update the frequency. If we use linked list, then if we always like, how can we yeah, we need a data structure that can store the key and the counter and its counter, and it's easy to update. Maybe just use a counter, and so it. But we need we can have maybe two data structures, like a map. It will be key to node, and we will have a counter that will be key to frequency, and then we will have doubly linked list, to maintain the to determine if there is a tie. But then if we use a counter, we are not sure who is the least. Every time we need on to remove the least frequently used key. I want to check how they do it. Okay, so I have read the solution, and it simply is the LRU a more complex mode. We'll first have the node class. So this node, and we still use the linked list, and there will be a mapped key to node, and there will also be a map. We will have several linked lists. Map with frequency to linked list. Okay, let's first have the node. So it's constructor self value equals default to 0, and prev default to none, next default to none. And I forgot key. We need key because when we remove the last node, we are removing from the tail node, and we cannot know the key first, so we should get the key from the node. So we need the key property. Okay, and then solve key equals key. And all the other properties. Let's have next. Okay, and then let's move on to our cache class. So first of all, we will have our capacity, and we need a map this key to node map, yes, and this will be key was node. I think maybe we should also add frequency so that it is easier for us to, since the other map is its key is frequency, so we need we need frequency to find a node in the linked list in this map, in the second map. Okay, so key to node, and it will have like key, node, and frequency, and we'll have the map frequency to let's say dummy node. Yeah, we will use the dummy node as the linked list head, and it will also be the tail. So yeah, we'll have this. It will be a default date. It should be default to a dummy node. Yeah, there is like because we need a new type, so we need to define here. And this will be our head will equal to tail and will equal to our node, dummy node, and head next is tail, prev is head, return head. Okay. Oh, we can add frequency into the node. So then we don't need an array to keep track of this. Okay. When it is initialized, it will definitely be 1. Then let's start implementing get. So if key not in the dictionary, key to node dictionary, then just return -1. If it is in the dictionary, then we return its value. Return key to node key value. And then we have to update its frequency. So its node is so node frequency added by 1. And after then, when get we should update the frequency, and then it should move from the frequency 1 this node to frequency this node. So we need to remove it from its. We will add it later. We need to remove it. Remove the node from its frequency list, and then add it to the next frequency list. Add it to the head of the next frequency list. So let's remove. So the head will be let's take the frequency to dummy. Use this its net frequency to get the linked list, and now we have its linked list. We had the node. So remove will be node. Its previous will be equal to its next, and its next, its previous next. Let's have prev node equals remove it from this frequency list. It will be prev node equals node prev, and next node equals node next. Then let's remove. We will pointing prev node next to next node. And we also will have next node previous pointing to prev node. Okay, added to the head of the next frequency list. Okay, so the next, okay, then now we can add it by 1. This is the next frequency list head, and we will have node next equal to head equal to add next, and node previous will be head, and yeah, and now next previous will be node. And head next will be node. Okay, then we finish adding, so when we remove, we should yeah, let's first do this and then we'll put, so then we should first check if this key if key in key to node, then we will have the node like this, and we will remove the node from its frequency list and then add it to the head of the next frequency list. We'll do the same thing as here and also update its value. I think we can have like remove, yeah, we don't need it. Remove, we only need node, so yeah, node list node none. So we'll call self remove, and then yeah, add to head, but with frequency int, and yeah. So add it to the head of specific frequency list. So we will have frequency and add finish. So this will be self add to head node frequency. Okay, and for this, put if key is in the node in the dictionary, then we will update its value. Then we will remove the node and then add frequency 1 and add to head. Else, if it's not in the frequency, it's not in the current dictionary, then we should check if capacity, if length of the dictionary is full. If it's full, then we need to remove. Then we will have a node. We will remove the list frequency, the tail node of the list frequency list, and then we will add the new node to the first frequency list, and also we need to add the new node to dictionary. And remove the tail, and then we need to remove the node from dictionary. Okay, so remove the tail node of the list frequency list. Okay, for this we need to maintain a min frequency. So yeah, we should add it here, like self min it will be default to 1. Wait, maybe if capacity will be 1, so I think we can default to 1. get the least frequency. Yeah, the least frequency will be min. Okay, frequency. Wait, yeah, because we need to get the tail node. So tail equals self frequency to dummy, then it's min frequency. Then we will remove tail. Called removing node will be tail previous, and since tail is also a dummy, so we will then remove the node from the dictionary. Okay, so removing node, it's okay, so self key to node. Yep, we will pop removing node and its key. Add the new node to, okay, the new node will be list node key value. Okay, first frequency list, it will be head 1, and it will be like this. Oh, we don't need to do this. We can have it like add to head with frequency 1. Wait, and node. We need to input node. Oh, then we can, yeah, we don't need frequency. We will have node frequency. Yeah, so no need frequency. We will have node because the default frequency is 1, so it works. And add the new node to the dictionary. So self key to node will be key equals node. Okay, and then else if capacity is still enough, then we don't need to remove the node, so we will directly add the new node to the first frequency list and the head of and then add the new node to dictionary. So I think we can just copy we can do it like else and if. Else if then then we don't need this. We need to update the min frequency. Whenever we remove, frequency may be changed. And when we are here, we should we will change our min frequency to what? Reset min frequency to what? So min frequency to 1, and other times when we remove, we will check we need to check if there is no current node, there's no other nodes besides. So if I think if we need to update every time we remove a node, but the question is how to update. Check the solution. If self frequency to dummy with node frequency, if this had check if the removing this is empty. So head equals if head previous if head next is head, then it's empty. Then we will if it's empty, then we will add and yeah, we should check if the min frequency is pointing to this list. So if head equals head and so then min frequency equals to node frequency. Then yeah, it now becomes empty, so we will add min frequency by 1. Yeah, I'm thinking what if the min, like if 1 to 2, if original min frequency is 1, then it becomes 2, but 2 is also empty. If 2 is empty, then we will add node. Yeah, then that means no nodes are in this cache instance. So yeah, we will add node and we will reset. So that's why we need to reset. Init. Oh,